Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Made in the Shade, a Hayawake Chaos Construction puzzle by Mello Robinson and Sunny K. And here are the rules. We have Chaos Construction, where we need to divide the grid into 9 orthogonally connected 9 cells regions and draw their borders and place the digits 1 through 9 once in each row, column, and region. So what is an orthogonally connected region? Well, an orthogonally connected region means you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this is a valid example of an orthogonally connected region, because for every cell in this region, you can go to any other cell in the region just by going through edges while staying within the region. So to go from here to here, you would have to go through these edges here, but you would be able to just by staying within the region. This is not as an example of an invalid orthogonally connected region, because while these two cells can go to each other by going through edges while staying within the region, they cannot go to any other cell in the region by going through edges while staying within the region. They either have to go through a corner or they have to exit the region entirely through an edge, which is not allowed. So that's an example of how orthogonally connected cell regions work. Okay. We have white region dots, where values in cells joined by a white dot are consecutive and belong to the same region. So these have a white dot between them. So say there was a 6 here, this would have to be 5 or 7, and they would have to belong to the same region. We have black region dots, where values in cells joined by black dots are in a 1:2 ratio. That is, one value will be double the other, and they belong to different regions. So say we had a 2 here, this would have to be 1 or 4 to maintain the 1:2 ratio, and these would have to be different regions here. And they have asterisks because I think they can apply to the corner dots, right? Corner region dots, dots on cell's corner, join two diagonally adjacent cells pointed to by the arrows. So these join specifically these two. This black dot specifically joins these two as a 1:2 ratio. This black dot joins these two into 1:2 ratio, and these as a 1:2 ratio. And I think they also have to belong to different regions. So these must be in different regions. These must be in different regions. These must be in different regions. This white dot on the corner joins these two cells, and they must be part of the same region here. So corner region dots are basically like dots on a line. It's just that they join specifically the cells that are pointed to. So it would be these two must be in a 1:2 ratio and are in different regions. These two must be in a 1:2 ratio and are different regions. These two must be in a 1:2 ratio and be in different regions. These two must be consecutive and must be in the same region. We have Hayawake, where we need to shade some cells so that no two shaded cells are orthogonally adjacent, and the remaining unshaded cells form one orthogonally connected area. And there cannot be a horizontal or vertical line of unshaded cells that goes through two or more region borders. Okay, so yeah, this. I've seen actually a decent amount now of Hayawake with Chaos Construction, and it throws me off a little bit because you don't have enough colors. But anyways, let's draw some borders. So, say we had say we had a border here, a border here, and a border here. You could not have a run of unshaded cells crossing two borders. So this is not allowed here. You could have something like this, and then something like this. And this would be allowed because it's crossing one border here. It's crossing one border here for the unshaded cells. And all the shaded cells cannot be sharing an edge with any other unshaded cell. And all the unshaded cells must form an orthogonally connected area, which is the same as an orthogonally connected region, right? You have to be able to go from any cell in the unshaded area to any other cell in the unshaded area just by going through edges while staying within the region. So those are the rules for Hayawake, and this goes for any run of unshaded cells. You can only cross at most one region border. You cannot cross two or more. So that's how Hayawake works. We have squares where values in squares indicate the number of unshaded cells in all up to 9 surrounding cells. So say actually these were all unshaded, then this would be a 9. Say this was shaded here, then this would have to be an 8. And so forth and so forth. And it counts basically all 9 cells that are in a 3x3 area centered on the square cell. So that's how squares work. And finally, we have values, where a shaded cell containing digit x has a value of 2x. Okay, so that's where we're going to have something interesting. Oh, that's going to be crazy. We don't even have the regions set up. Interesting. So a shaded cell in the Hayawake containing digit x has a value of 2x. So say we had a 3 in a shaded cell here, then its value actually would be 6 and not 3. An unshaded cell containing digit x has value x. So an unshaded cell is a normal coloring. In other words, shaded cells are doublers, right? So the value of this would be a 3. Say we had a 3 here, this would actually be just a value of 3 there. But that's for shaded cells, but that's going to affect... Oh, that's going to be crazy. Okay. Okay. Yeah. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, oops. So, we know all the black dots are region borders. So this is region border, this is region border. Region border here, region border here. Region border here. All the white cells are in the same region. So we can't do numbers yet. Well, we can do actually numbers with the doubling. Because the doubling... Can we? Ooh. Well, if they're in the same row or column, we can. Right? Because even with doubling, you can only do so much in a row, right? So if we have shaded values in a row, The only thing that really changes is that like 1 could be doubled up to the value of 2, right? Or 4 potentially could be doubled up to the value of 8. 2 could be doubled up to the value of 4. But the thing is, these essentially have to have the same relationship for the most part. So the only case that... So these are different regions. That doesn't help us much right now. But to be in a 1-to-2 ratio with 2 other unique values, you still can't have 3 and 6 actually be that way, right? It would be 6 and 6 if one of them's doubled. But if both of them are doubled, then it's the same thing, right? 6 to 12. So it would basically still have to be 2 in a 1-to-2 ratio with 1 and 4, or 4 in a 1-to-2 ratio with 2 and 8. Now, the 2 value could be different. The 4 value would not. And in fact, it has to be some sort of 4, 2, and 8. Because this would be crossing 2 borders here. If they were all... well, they could be all... They can't be all shaded. So then it has to be 4 with 1 doubled and 8, necessarily. Because one of these is going to have to be doubled. The 4 cannot be doubled. If you double 2, you have 2 values of 4, and you have an 8. But that's not going to work. Oh, 8 could be between 4 and 4. Oh, that's interesting. So you could do that. So one of these values has to be doubled. So you could have... Okay, what are the possibilities? You could have 2 in the middle, 1 and 4, but that doesn't work. Because all of them would have to be unshaded. Which means none of them are doubled. Which means you would have all of these unshaded going through 2 region borders, which is not allowed by Heiawake. So 2 within the middle with 1 and 4 does not work. 4 as a digit could be in the middle between 1 doubled and 8. So this could be 4 with 1 and 8 doubled. But that's not the only possibility. You could have 8 here between 4 and 2 doubled, right? So that would be a value of 4, a value of 4. So we know this is unshaded. And one of these two is. So this is 4 or 8 here. This must be then 1, 2, 4, 8. We are guaranteed a 4 in this row. And we're guaranteed 8. So this is 4 and 8, which means this cannot be 4 and 8 as a pair. This has to be 3 and 6 as a pair. And they have to be the same shading. They are in different regions, but they are the same shading. Because they must be in... And they can't be both shaded. They must both be unshaded to be 3 and 6. So this is unshaded here. If this is unshaded, you would have an unshaded section all crossing 2 region borders. So this must be shaded, which makes this unshaded here. So if this is, if this is 4 in the middle, it's next to 1 doubled, which would be here, and 8 unshaded. If this is 8, it would have to be next to 2 shaded. And then this would be 4. So this is a 4-8 pair here. This is in... These are in the same region. And this would have to be the case either way, right? So because if you have a region border here, then that doubly applies to this, right? If this is green, then you'd have 3 region borders. Well, it doesn't really matter, but yeah. These are in the same region. These are in different regions. These are in the same region. This must be in a 1 to 2 ratio with another digit, so this has to be the other 1, 2. Which leaves the remaining digits in row 5 as 5, 7, 9, because 5, 7, 9 is never going to be in a 1 to 2 ratio with any digit, any other digit in the same row or column, because you can't repeat a digit. So this is 1 and 2, which could be with 1, 2, 4, or 8 here. This must be an odd value. So you either have 4 here, and that's 2 in value, or you have an 8 here, and this must be... Well, we know these are unshaded. So we know these are unshaded. These are the same region. These are the same region. These are the same region. This is a different region than this. These are the same region. This must be an odd value, so that's green. Since this is unshaded, if this is 1 doubled, and with 4 and that being 8, this would have to be either 2 or 8 in that instance. If this is 2 doubled, with 8 and 4, this can only be 4. Okay. Let's try to use coloring to be the same region. So we have, we can't use green or blue. Oh, these are different regions, right? These have to be different regions because they're in a 1 to 2 ratio. So therefore we know this is the same region as these. So these have to be the same region here, which means this has to be a different region. So these are different regions. So therefore these are the same regions. These are the same regions. So this must be different from this cell. So this region has to go down that way. This region has to go here. So this is red, this is green and green. It cannot have a green here. This must be blue. So this is the other that's doubled. Interesting. This cannot be blue. It must be green. This is green. So the value... Okay, so... So what are the possibilities then? This is 2. So if this is 1 doubled, that's 2 in value. That forces this to be 4. If this is 2 doubled, that's 4. It must have an 8 there. So those are the only possibilities there. 3 and 6 must be in a ratio with... This has to be doubled, right? These are single values. Therefore, this must be doubled, and it's the other... So this has to be then 3 here and 6 here. So let's remove the red for now. If this were 6, that would force this to be... Oh, you could have 6 doubled. So either way, this digit is the same as that. And this is consecutive with that digit, which is green. So this cannot be 6 and 6 doubled, because that's 12 in value, which is not going to be consecutive with a single digit. So this must be 3 here. That's 6. This is 3 doubled. So this is 6, which means that's consecutive with 5 or 7. This is doubled in a 1-to-2 ratio with this, so this has to be doubled. That means these are green. This is 5 or 7. It's the same digit. This has to be green. Interesting. These are the same region. This cannot be 3 or 6. So this has to be 1, 2, 4, or 8 here. To be in a 1-to-2 ratio. Because they're in the same row. This can't be 3 or 6, so this is also 1, 2, 4, and 8. This could be blue. So this is in a 1-to-2 ratio with both this and this and this. So it's in a 1-to-2 ratio with 3 digits. So obviously this has to be, okay, so if this is 2, so say it's, say it's digit 1. Oh, these are consecutive. Well, we know 5 is only consecutive with 2 doubled. And 7 is not consecutive with either. 1, and that's it. So this must be 2 doubled. This must be 1 doubled. So 2 and 5 are there, and this is 5 doubled there. 2 is doubled is 4, which is next to an 8 only. This is 2 doubled. So 2 doubled is in a 1-to-2 ratio with 4, which makes that 8. So one of these two has to be 1 doubled. The other one has to be... Sorry. One of these... So this is 2. One of them is 1, and the other one is 2 doubled. So this is 1 and 2. But we don't know which one. This green... This square has 8 unshaded cells around it. One of these is the shaded cell, so this must be unshaded here. This is 5 and 3. This is 4 in value, so this has to be 2 or 8. This is 8 in value, must be 7 or 9. They are part of the same region. We don't know where the 4 goes. These are part of the same region. This is a different region, but we know it's already part of that region. And this could still certainly be part of this region. We have 2 or 8 here. If we have 2 in value, it must be an odd digit. So this is green. Or same with 8, right? So this is either, cannot be 1, it's 3, 7, or 9 here to be consecutive. This is 2 in value. So this can't be 1. Which means this must be 3 to be consecutive with it. So this is 3, which means this cannot be 3. Therefore, this is 7 or 9, which is not consecutive with 2 in value. So this must be 8. Okay, so this is not the same region as this. Okay. This has 3 green cells. You can have at most, how many blues? I think it's 3. So this is at least 6. So we have, it can't be 6, it's 7, 8, or 9 here. Okay, we know this cannot have a boundary. Obviously, all the circles, white circles cannot have boundaries. That's all we really know there. Hmm. These two are the same region. Hmm. These are the same region. This is a different region than that. This is a different region than that. These are different regions. This is the same region. And these are different regions. So this is definitely a border. But we still could have a border here, right? This is 6, which is in a 1-to-2 ratio. And it cannot be 3 here. So this must be 6 also. And this is shaded. So this must be unshaded here to get out. These are all unshaded. This has to be this has to be in the same region. If we have a border here, the problem with that is this would go through 2 border areas. So this cannot be a border here, which means this is a boundary here. So this must go out here. So this is all one region here. So this is a different region. Therefore, this must be blue because we can't cross 2 borders with unshaded cells. This is blue. That forces this all to be green. This must be green also. This could go this way. This could go that way too. So this is the same region, which means no 2, 3, or 5. So 1, 4, 6, 7, 8, 9. Obviously no 8 here. No 6 here. This is a different region, so this has to go that way. These are the same region. We have 6 cells here. This can go at 7, 8, and 9. That is possible. Remaining digits in this region, that's kind of curious. So this is 1, 3, 4, 6, 7, 9. And this can be 1, 2, 4, 7, 8, 9. And these must... Oh, this doubled must be 1 away from this. So this can't be 8. This must be 7 or 9. It cannot be 9 because you don't have 9 cells around it that are green. So this has to be 7. 7 is consecutive only with 4 doubled. So this is 4. Which means this can't be 4. No 4 in the box. No 7 in the box. This can't be 4 in the box. Okay. Because this can't be 4 and these are not doubled, this can never be 8. This is all the same region. So we don't need a blue in any of these. We could have one, but we don't need one. We definitely have one blue here, though. We don't know which one. Hmm. Remaining digits in column 3 are 1, 2, 4, 8, 5, and 9. So no 8 here because of 8 in the row. No 5 here because of 5 in the row. Okay. These are consecutive. One of them at least is green. This has to be the same region, because otherwise you'd have all shaded cells there. Or sorry, you would have to have you would have unshaded cells going through 2 region borders otherwise. This cannot be a boundary, because if it were, this unshaded region would go through 2 boundaries. So this must be boundary here. This must be boundary here. This cannot be a boundary for the same reason, because that would be an unshaded cell going through, unshaded cells going through 2 regions. So this must be boundary here. So this is part of the same region as this. This has to be 9 then. There's no 8 or 9 here, which means we have a 1, 2, 4, 8 quadruplet in column 3. So no 1, 2, 4 here, no 1, 2, 4, 5, no 4, 8 here. So this is 5, 9 as a pair. This is part of this region now. Well, yes, because it cannot be part of this region. So this is bound there. This is then goes there. 1 and 3 has to exit out this way. This is 1, 2, 3, 4, 5, 6, 7, 8, and it must exit out this way as 9. So that's boundary there. This is the boundary there. 5 eliminates 5 in the rest of the region, so this is 9, which eliminates 9 in the rest of the region, so that can't be 9. This can't be 6 because of 6 in the region. Remaining digits in the region, this can't be 2. We have 1, 4, 7, and 8. 4 can't be here because of 4 in the column. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's done as a region. So we cannot have 9 or 8 in the rest of the region. We can't have 4 in the rest of the region. We have a 1, 2 pair in the region, which eliminates 1 and 2 in the rest of the region. So this is 3, 6 as a pair. One of these is guaranteed to be 2. We're not sure which. Either way, if this is 2, this can't be 2. If this is 2, this can't be 2. So this is 1, which makes this 2. Therefore, this can't be 2 or 1. It's 4. This can't be 1 or 4, which means this must be 8 here. And it's 8 normal with 2 doubled. So this is 2. 8 eliminates 8 in the rest of the region. So this is 1, 7 as a pair. 1 eliminates 1 here, so it's 7, which makes this 1. This can't be 1 or 7. It's 4. 9 eliminates 9 here, so that's 5. This must be going out as a region there. Remaining digits of column 1. We have 1, 7, 9. Obviously no 1 here. Remaining digits of column 2. We have 8 and 9. So this cannot be part of the regions here. And it can't have an 8 in that region. It must be 9. I guess it can't go out this way because that would guarantee a 9 here and a 9 here. So this must be 9 here. This is 8 here. This is a border here. And this 9 eliminates 9 in the rest of the region. So this has to be 9 here. We have 9 here. This is 7. That's 1. Blue cannot be sharing an edge with another blue. So these are green. This has two green borders, or sorry, two unshaded cells going through a region border, so this can't be green. It's blue, which makes that green. Green has to orthogonally connect, so that's green. This is part of that region because it has to exit out. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is part of that region. It has to be 4 or 5. This must also go out that way, so this is a border there. Okay, this has to exit out that way. So this cannot go up because this has to exit out, and you can't combine these regions because we have 2 3s and a 1 already. So this must go out there. There's a border here. This then has to continue out here, so this is done there. And this cannot be 4 because of 4 in the column. So this is 5, that's 4. This must go out 6 there at least. This has to go that way. So this is a separate region than this. So this is border. We don't know if these are the same region yet. So no border. Okay, so let's clean these up. We now have all of that ready. These are the same region. This is 6 of the same region. Remaining digits of column 4. We have 2, 5, 6, 7. Obviously no 2 here, no 7 here, no 7 here, no 5 here. Remaining digits of column 5, we have 3, 6, 7, 9, 7, 8, 9. No 7 or 8 here, no 8 or 9 here, no 7 or 9 here, no 7 here. So, where are the 7s in these columns? One of them has to be here. One of them has to be here. So this could be 7 with 6 or 8 or 3 doubled. So this cannot be 9. This cannot be 5. Okay. Heiawake. 2. This is 2 borders, so this must be blue. Sorry, 1 border. This must be blue. Because that's a second border. That's why it's 2 borders there. So this is blue, this is green, which means this is 1 doubled. This is 2. There cannot be borders here and here. This cannot be 3 because of 3 in the region. One of these is 7. So we have a guaranteed 7 here and a guaranteed 7 there. And obviously 7 doubled wouldn't work because that's not consecutive with another digit. We have 9 here, which means this can't be 9. This is 7. Remaining digits in row 6 are 2, 4, and 5. Well, the only one that's consecutive is 5. So 5 cannot be here. So 5 has to be a value there. Remaining digits of row... This cannot be blue. Green has to go extend out to orthogonally connect. We have two boundaries here. This cannot be green. This must be blue, which makes that green. One of these has to be green to orthogonally connect out. Then the other one must be blue because they can't both be green. So one of these is green, one of these is blue. That doesn't help right now. Okay. These are same region. This is obviously same region. Remaining digits in row 7. We have 2, 3, 4, 5, 6, and 9. Okay, so this is 6 or 9 in value. 6 can be next to only 5 and 7. 9 can only be next to 4 or 5 doubled. Okay. It can't be 8 because of 8 in the column and row. This is going to be either a 5 in value, which would force that to be 5, or a 4 in value, which would force this to be 2 or 4. Or 1. Well, you can't have a 1 in the row. So, interesting. So this value is going to be 4 or 5. Even if it's 4, then it can only be next to 5 or 3. That could be 3. If it's 5 in value, this has to be specifically. Oh wait, this is a 1-to-2 ratio. I don't know what I'm thinking. Okay, this is 4 or 5 in value. If it's 5 in value, this must be 5 doubled. If this is 4 in value, it could be 2 in value or 8 in value. So this could be 4 also. But we don't know. Right. These are the same regions, so this has to be a different region here. So this is definitely a border. Huh. Remaining digits of row 8. 3, 6, 7, 8. This obviously can't be 3, because 3 unshaded cells would mean that 2 shaded cells are sharing an edge. So it's 6, 7, or 8. We have shaded cells crossing one region and cannot cross another, so this is blue. Which means these have to be green. Six cells in the same region. Remaining digits in column 6, 1 through 6, and 9. Obviously, no 5 or 9 here. 1, 2, 3, 4, 6. Remaining digits of row 4. 1, 6, 7, 9. No 7 here because of 7 in the column. Um, hmm. If this were shaded, it would have to be a 6, which is not going to be, which means doubled, it would be 12. Which means that this would never be consecutive with it. So this cannot be shaded. This is green, which makes this shaded here. Um, This could still be shaded. So we have either 6 here with 7 here, or 7 with 3 doubled, 6 or 8. Okay. Remaining digits of row 4. We have 2, 3, 4, 6, and 8. No 8 here because of 8 in the column. These are the same region. We don't know anything about this. You know, that's all the same region. So let's check the Heiawake we have for certain. 0 boundaries, 0 boundaries, 1. 1, 1, 0. 1, 0, 0. 1, 0, 0, 0. Okay. Technically, this could all be that same region, right? 1, 2, 3, 4, 5, 6, 7, 8. That could be. We don't know anything about that either. This is all 6, so there's no boundaries there. Oh, one of these is blue, right? That's one thing we know. Same region. Same region, different region. Okay. This is same region. We need an odd value here, but we have plenty of odd values. But the thing is, those don't really work, right? I guess you could have 5 with 6 or... Can't be 4, obviously. You could have 9 with 5 doubled, or 8. You cannot have 1 there, though. Okay, so 1 can never be here. Even, well, you could have 1 doubled with 3. Never mind. Remaining digits of row 1. We have 1, 3, 5, 6, 7, 8, 9. I don't think we could have 6. 7 cannot be there, though. Because we know 7 has to be one of those. This can't be 8 because of 8 in the column. This can't be 7 or 8. Oh, that's interesting. Because of 7 or 8 in the column. This is all done. This is all done. Let's check the dots. 2 is in a 1 to 2 ratio with 4. 4 times 2 is 8, which is consecutive with 7. 5 is in a 1 to 2 ratio with 5 doubled, which is 10. 2 doubled is 4, which is in a 1 to 2 ratio with 8. 2 doubled is 4, which is consecutive with 5, which is consecutive with 3 doubled, which is 6. Or sorry, yes. 8 and 9 are consecutive. 3 is in a 1 to 2 ratio with 3 doubled, which is 6. 3 and 6 are in a 1 to 2 ratio. 6 and 6 in doubled is in a 1 to 2 ratio, with that makes that 12. 8 is in a 1 to 2 ratio with 2 doubled, which is 4. 2 doubled is 2, which is consecutive with 3, which is in a 1 to 2. Oh, wait, no, this is incorrect. This has to be 2 doubled. Right. Okay. Oh, that helps us solve this then. Okay, so we didn't really use this for anything. So this is not 1, this is 2, that's 1. So 1 doubled is 2, which is in a 1 to 2 ratio with 2 doubled, which is 4. It's also in a 1 to 2 ratio with 4. It's also in a 1 to 2 ratio with 1 single. So this cannot be 1. This is 2, 6, 7, 8, 9. This can't be 2. This is 1, 4, 5. 1 doubled even is not in a 1 to 2 ratio with 5. Or sorry, it's not consecutive with 5. It's also not consecutive with 4. So this has to be 4 and 5. And they have to be both green. Which means this can't be 4, 5. It's 1. These are in the same region. We don't have any information there. So this is 4 or 5. 1 eliminates 1 here. So this still could be 2, 4, or 5 here. Right, so we didn't use this at all. This actually helps us in solving this part. So that's good, I guess. We have 8 unshaded cells around this box. We have 7 unshaded cells around this box. Or square. One of these is green, one of these is blue, but we don't have any information about that. Here we have either 3 shaded cells around this, up down to 1. We're not sure. 5 has to be one of these two, but that doesn't really help us much. These are definitely different borders. So these are different borders, these are different border, or different regions. Different region, different region, different region, different region, same region, different region. Different region, different region, different region, different region, same region, same region. 4 either has to go this way, or it could go both. Oh, 8 cannot be part of this region here. If it's part of this region, then the 4 is blocked out as a region, and it's stuck. So this has to be a border here, which means this is a border here, which means there cannot be a border here, because then this unshaded cells would cross 2 borders. So this is definitely not a border here, right? Because even if it contains this, it has to go out this way, because it can't go out that way, because these are separate regions. This cannot be a border, because if that's a border, we'd have unshaded cells all through that region, or through two borders. Therefore, these are the same region. We could have a border here. We don't know. Oh, this 7 eliminates 7 here, so it's 5 or 9. There has to be another 7 here, which means this cannot go all the way through the border here, which means at least one of these has to be blue. This cannot contain 4 because it's in the same region as that. This can no longer be part of this region because this has a 1 and this has a 1. So these are separate regions here, which means this is going across one border, cannot go across 2, so this is blue, which means this is double, which means this is single, so this has to be 9, which means 9 cannot be in the rest of the column or row, and this is 4 or 5 double. These have to be green. Because this is green, these are part of the same region. There's no border there. This must be a separate border there, then. This must go to here. So it cannot be part of this region, so that's a border there, then. These are separate regions. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9. That is possible. Green has to orthogonally connect, so therefore this must be green, and this crosses one border, but it can't cross 2, so this is blue. This has to be green then. This needs access to a 3. I think, well, it could... Okay, so this cannot go down here. So this necessarily goes this way. So then we have, that's a border, this is a border. So this is at least 8 cells. We have 1, 2, 3, 4, 5, 6, 7, 8. That's also 8 cells. So then this has to be full 9 cells that way. So this could potentially go up here. So if this is the same region as this, the problem is we have extra cells here, which can't be part of that. Well, you could do 9 here. You could go down here. Okay. That's potentially possible. So this is all done as a region. This has to be going through one border, so this must be blue. We have to connect the greens, so therefore this has to orthogonally connect that way. And these are all green because they're next to a blue. This cannot be green, because if this were green, it would necessarily have to cross 2 borders. So this is blue, which means this is green. You have to orthogonally connect, so that's green. This is then either 6 unshaded cells or 7 unshaded cells. Cannot be 8. This is double of that, no matter what, so that's not 2. This is 4, 5 as a pair, which eliminates 4 and 5 in the rest of the column. No 4 here, no 5 here. Remaining digits of row 9 are 1, 2, 3, 4, and 6. No 4 here because of the 4, 5 pair in the column. These are all part of this region. So these cannot ever have a 3. Where is 3 in row 8 then? It has to be here. So this is 3, which means this is a border here. So this must be going this way. No 3 here. This is 6. No 3 or 6. This can't be 6. This is 7. This can't be 3, 6, or 7. It's 8. This 4, 5 pair eliminates 4, 5 in the rest of the row. This can't be 6. It's 2. This can't be 2, 4, 5, or 3. So that's 6, which makes this 3. That means this can't be 3 or 6. No 3 here or 1. This can't be 2 because of 2 in the column. This can't be 2 because of 2 in the column. We have a 6, 7 pair in column 4, which eliminates 6, 7 in the rest of the column. So this is 5. 6 eliminates 6 here, and 6 here. Also 6 here, and 6 here. No 3 or 6 here, no 3 or 6 here. Okay, no 3 here because of no 3 or 8 here because 3 or 8 in the column. So this is done as a region. This is done as a region. This has to go out here. And this cannot be part of the same region as this. So this must be a border. This has to be able to extend out here. This has to be able to extend out here. So we have border here, border here. This is 1, 2, 3. Okay, this can't be 6 because of 6 in the row. This can't be 7 because of 7 in the region. So this is 9, which makes this 5. That's 7. No more 9 here. This can't be 7. This can't be 7. Where is 7? We have a 2, 9 pair now in row 4, which eliminates 2 and 9 in the rest of the row. This can't be 2 or 9. It's 7. This can't be 2 or 9. It's 6. This is a separate region than this. So we have 1, 2, 3, 4, 5. We need access to a 4, and it's not going to be here. So if we had this as part of this region, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. We don't have access to a 4. So these have to be separate regions. Okay, so then we can clear this out. We can clear this out. We need access to a 4. It has to either be here or here. So this is part of that. So this can't be 6. There's no 6. This has to extend out more, so it can't go this way. It has to go this way. So then this is a How did I get that? This is a region going that way. This extends out there. So we need 4, so 4 has to be there. Which means this can't be 4. We have 2, 3, 8 as a triplet in row 4, 3, which eliminates 2, 3, 8 in the rest of the row. This can't be 3 or 8. It's 6, which eliminates 6 in the rest of the column. This can't be 4 anymore. This can't be 5. The remaining digits in column 7 are 2, 6, and 9. This can't be 3 or 8. It's 2, which makes this 8. It makes that 3. 8 eliminates 8 in the rest of the column here. 2 and 9 can't be here. This can't be 6. This can't be 2. Remaining digits in column 8 are 1, 3, and 8. No more 3 here. Okay. This has to, one of these has to be blue. We don't know which. This has 7 green cells in the 3x3 box around it, so this is green. These are consecutive. Okay, one is not going to be consecutive with any of these, even doubled. 3 doubled is 6, which doesn't work here. So this has to be 8. 8 and 9, right? Yeah. So this is 8, this is 9, which eliminates 8 and 9 in the rest of the row. We have a 3, 6, 7 triplet, which eliminates 3, 6, 7 in the rest of the row. So this can't be 3, this can't be 9. We have 1, 5 as a pair here. This is all one region. This is part of that region. You cannot have 4, 5, 3, 6, 7, 8. So this is 1, 2, 9 remaining. 8 eliminates 8 here. 9 eliminates 9 here. This is 2. This is part of that region, so this is 9. We have green around one region, so this must be blue, which makes these green. Since these are green, this is green going across one region border, so this must be blue. Green has to orthogonally connect, so that's green there. This is green going across one region border, so this must be blue. That forces this to be green here. I don't know why I did that. Anyways, this is still pretty wide open. Okay. We have 1, 2, 3, 4, 5, 6, 7, 8. It could go 9 here or 9 here. We're not sure. These are both green. They cannot be blue. Remaining digits of column 6. 1, 2, 4, 5. No, 4 or 5 here. Okay. Pretty broad. These are all the same region. We need a 6 and a 5. And an 8. Well, okay, this can't be part of that region because we already have 1 and 2 in that region. So this is boundary. That means this is blue. So that makes this green. This can then only go this way. We need access to a 6 and a 5. 6, 8, 5. It can't go through here. So this is boundary here. Then it must be full that way. And this can't be 3 because of 3 in the region. So this is 8. This is 3, 7 as a pair. We don't have 9 remaining in row 2 except here. So this is 9, which makes this 2. That eliminates 2 here. Can this not be part of this region? The answer is no, because this would go that way. This 9 would have to go out this way and would connect to this. So this is all part of the same region. Interesting. So this is all part of the same region. So we don't know anything about these. Okay. Let's go Hayawake. Okay, so the green region is not orthogonally connected. So it must orthogonally connect here. It cannot be 3 doubled here now. So this is 7 and this is 6, which makes this 3 and 6. This can't be 6, it's 2 and 1, which makes that 3. 1 eliminates 1 here, so it's 5 and 1, which eliminates 1 here. So that's 4. This can't be 1. This 5 eliminates 5 here, so it's 4. No 1 or 4 here, it's 2, which makes that 6. 4 eliminates 4 here, so it's 5, which is doubled of 5 there. That's 4. This is 1. And these will be filled out. We just want to fill this out. So this is guaranteed to be part of this region because this can't reach there. So this must be going all the way over there. This is done as a region then. This is all green. This cannot be green. This must be blue, which makes this green. The green has to orthogonally connect, so that's green. And we should have the Hayawake working. Okay. Let's do the Kropke dots for now. We have 2 and 4 are in 1 to 2 ratio. They're different regions. 6 and 7 are consecutive. They are the same region. 8 and 9 are consecutive. They are the same region. 4 doubled is 8, which is consecutive with 7. They are the same region. 5 doubled is in 10, which is in a 1 to 2 ratio with 5, which are different regions. 9 and 8 are consecutive, and they are the same region. 5 and 3 are, this is 5 and 3 doubled, which is 6, which is consecutive, and they are the same region. 5 and 2 doubled is 4, which is consecutive with 5, and they are in the same region. 3 and 3 doubled is 6, which is 1 and 2 ratio. They are different regions. 3 and 6 are in 1 to 2 ratio. They are different regions. 8 and 4 are doubled. They are in a 1 to 2 ratio, and they are in different regions. 1 doubled is 2, which is in a 1 to 2 ratio with 1. 4 and 2 doubled, which is 4, and they are all in different regions. 4 is in a 1 to 2 ratio with 8, and they are different regions. 2 doubled is 4, which is in a 1 to 2 ratio with 8, and they are different regions. 6 is in a 1 to 2 ratio with 6 doubled, which is 12. They are different regions. 2 doubled is consecutive with 3. Sorry, 1 doubled is consecutive with 3. 2 doubled would be 2. But 1 doubled is consecutive with 3. That's 2 and 3. They are in the same region. 8 and 7 are consecutive. They are in the same region. 4 and 5 are consecutive. They are the same region. 8 is in a 1 to 2 ratio with 2 doubled, which is 4, and they are different regions. 9 is consecutive with 4 doubled, which is 8, and they are consecutive and in the same region. 5 doubled is 10, which is in a 1 to 2 ratio with 5, and they are in different regions. So those are all the dots. We have, I guess we should let's do squares. That's easier. 7 unshaded cells around this 3 by 3. 8 unshaded cells here. 7 unshaded cells here. And Hayawake. Okay, this goes through one region border. 0, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 0, 1, 1, and these are all 0. We have 0, 0, 1, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1. So the Heiawake is done, so we just finish this off. This is 3, and this is 7. Very cool, actually. Definitely hard. Not very hard. The logic throughout this was pretty solid. I just messed this small area up, and even then, it wasn't that bad because I didn't use it. In fact, actually correcting it led me down the path of actually solving. So, I was stuck here because I had the wrong digit anyways. So that's part of it. Very cool. The interaction between the Heiawake and the shaded cells and the 1 to 2 ratios was very interesting. And also the different dots giving you different region requirements was interesting also. Nice job. Nice job. This was a very well-constructed puzzle. As actually expected. Like, Mello, Robinson, and Senike do a really good job of constructing their puzzles. I've enjoyed a lot of both of their puzzles. And having them combined made a really good puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.